last three properties to talk through. Hey, the first is if the base of your exponent is a product, so if it has multiple factors, then that power is going to apply to each individual factor separately. So the product AB to the power of m is equivalent to taking the first factor to the power of m times the second factor to the power of m. And this includes multiple factors beyond this. So you could have 3, 4, 5 factors. That power is going to apply to each individual base factor. Right, if your base is a fraction, it's the same idea. The power of m is going to apply to both the numerator and every factor in the numerator and every factor in the denominator of your base. So the fraction a over b to the power of m is equivalent to saying a to the m divided by b to the m. Right, so those are very similar properties. And then the final rule is if your base of an exponent is an exponent itself, when you expand this out, you multiply their powers. So a to the m all to the n is equivalent to taking the product of those powers and using the same common base. All right, again, that should be review to you. I want you just to take another couple minutes here, see if you can answer these three questions on sample problem 5, please. All right, problem A applies this third rule here. You have a base that is an exponent itself, so you're going to take a power to a power rule. So we take our original power, -4, times our power 3, and that's going to give us our answer, x to the -12. So you could leave it in this form, or if you wanted to rewrite it using positive powers, that whole base of x would need to be moved to the denominator and change the sign of your power. Right. For problem B, here it's kind of a combination of these, both power of a product rule and power of a power rule. Here this power of 2 is going to apply to every single factor in the base. So the 5 gets squared. The base of x cubed gets squared. So when you take a power to a power, you multiply. And our base y to the 5th gets squared. Again, when you apply the rule, you take a power to a power, you multiply. So 5 squared simplifies to 25. Power to a power, you get x to the 3 times 2, or 6. Y to the 5 times 2, or 10. And so this would be the form of your solution, or simplified form. And then finally, problem C is the same idea. Every factor in your base is going to have a power of -4 applied to it. So I'm going to apply that power first. So in doing this, I take my base of 4 to the -4. My base of x, when I take a power to a power, I multiply the power. So -5 times -4 gives me a positive 20. My base of y to the -6 times -4 gives me a positive 24. And finally, my base of z squared, or 2 times a -4 gives me -8. Okay, I'm now going to just simplify. I'm going to take my bases that have the negative powers and move them into the denominator. So I get 4 to the 4th gets moved to the denominator. My base of x has a positive power, so it stays in the numerator. My base of y has a positive power, it stays in the numerator. My base of z has a negative power, so I'm going to move it to the denominator, change its sign. Okay, so this would be an appropriate form of the answer, especially if you're not using your calculator. If you are using your calculator, or if you have access to a calculator, I would expect that you could take 4 to the power of 4. So the other form of this would be just expand it out as much as you can. 4 to the 4th is 256. Z to the 8th. Again, I don't expect you to know that offhand, but if you had to do it, you should be able to do it with longhand multiplication pretty easily.